this is Donna coming at you. Today I wanted to do a lab with you guys about the kidney and the function of the kidney, specifically the nephron inside of the kidney, which you guys will remember is that basically the functional unit inside of the kidney. So for today's lab, let me talk to you about what we're going to need. Okay, so a couple of the items that we're going to use, we know that the kidney filters blood, so we're going to be using two types of simulated blood. You guys will have a data table in your lab that you'll need to fill in later. Just some basic lab equipment. We need a graduated cylinder, test tube racks, a few test tubes. This stuff here we'll get to in a little bit, but this is dialysis tubing. It kind of serves as a semi-permeable membrane, much like the cells of our kidneys. We're going to be using Benedict's solution, which is a glucose indicator test. We'll also be using just a simple sodium chloride, aka salt test, guys, as well as some pH strips. And these little guys are really handy. These are the dialysis tubing clips. You guys will see later in the lab what those are used for. Also over here we have our water bath, which I'm going to turn on because here in a few minutes we are going to need some boiling water. Okay? All right. So with that, let's get started, guys. This is a lab that I really wanted to do with you guys in class, but since we're stuck in an online world, I'm going to do it here for you and let you guys take a look, okay? All right, so let's get started. So I have gathered some material here. I have several different items that we're going to be using, okay? One of the most important items that we're going to be using, can you zoom in on this, is dialysis tubing. Okay? Dialysis tubing is actually a semi-permeable membrane, just like your cells, like the cells of your kidney would be. So we're going to be using this guy to simulate that. Alright, so the first thing I'm going to do with this dialysis tubing is I'm actually going to soak it in some tap water for about a minute. Alright guys, so that should be about a minute. So the first thing I'm going to do is I'm going to twist this dialysis tubing and I'm going to seal it up. So I'm just going to give it a couple twists, about 3. Okay, and then I'm going to use one of these little plastic dialysis clips to close it. So let me get this guy closed here. Maybe. Okay, well, hopefully that'll hold. That's going to be the trickiest part of this, is making sure it holds. Okay? All right. So the next thing we're going to do is we're going to carefully open the other end, and this might take me a second because this dialysis tubing is very tricky. Alright guys, so I got my dialysis tubing open. It is kind of a tricky thing to get it open, so it took me a sec. So the next thing I'm going to do is I'm going to fill this dialysis tube with simulated blood. We know that all of the blood in our body gets circulated through our kidneys pretty rapidly, about every hour or so. Okay, so I'm going to fill this dialysis tubing here up with this simulated blood. And one should note for this lab, you guys have a data table that you'll be filling in as we go through this lab. Okay, this is simulated blood A. Simulated blood A. Alright, so that looks pretty good. So I'm going to go ahead and I'm going to close this guy up and I'm going to use, I'm going to actually add just a little bit more simulated blood. Okay. And I'm going to do the same thing I did on the bottom. I'm going to twist it close, and I'm going to use one of my dialysis clamps over here. Okay? Alright guys, we're all good. No leaks. I went ahead and checked this guy. So what I'm going to do is I'm actually going to place it in this cup of water that I have labeled A. Okay? And then remember, this was simulated blood type A. So in your data table, it's important to know the first thing that you need to record in that data table is your color, clarity, pH, salt in parts per million, and glucose of your water. And I'm going to get you all of that data here in just a second. Okay, so we'll go ahead and we'll put that guy in there. So your initial observation for the color and clarity of your water is going to be, obviously it's water, so it's pretty clear, and its color is also clear. Okay? Go ahead and cut. All right, guys, in order to test the pH of the water, we need some pH strips. So I have a pH strip here, which I'm going to grab. And then I'm going to go ahead and I am going to dip it into the water. Okay, and we need to set the strip on a paper towel and observe the color after about 30 seconds. Okay, so I'm just... Alright guys, 30 seconds has passed, and we can see here if we look at the pH strip bottle, and it's just a colorimetric test, so we're just comparing color to color. We can see here our strip is very much yellow. We find yellow on there, pH of 7, which would make sense because water is totally neutral, equating to that pH of 7. Enzyme. One of the other measurements that you need for your lab is the initial salt concentration of your solution. Remember, we're just getting started here, so we just have simple tap water. So the instructions on this guy, dip in here, hold for 2 seconds. That's probably about 2 seconds. Let this guy dry for 20 seconds, and then we're going to check it. So let's do both of them side by side. That's probably about 20 seconds. So let's go ahead and take a look here. Show you guys on camera. These guys both match up pretty close with that 1500 ppm, which stands for parts per million. So there's a concentration of about 1500 parts per million of sodium in tap water, sodium chloride. Alright guys, and the last test we're going to do is a test for glucose, okay? So we are going to use Benedict's solution in order to do that, okay? So we need to obtain 5 mLs of Benedict's solution. Oops, got a little bit too much. Okay, it's important to have accurate measure, we know that. So we're going to do 5 mLs of Benedict's solution into our test tube, okay? And then the next thing that we need to do is we need to actually test our water here that's with our dialysis tubing, okay? So we're going to need 8 drops of this guy. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 drops of solution is all we need. A boiling water bath. I'm gonna have to put this in here for the next 4 minutes, and then we'll check our results in 4 minutes. Okay, off. All right, guys, and it's been 4 minutes in our hot water bath. So with my gloved hand, I'm going to reach in here and get this guy out. Zoom in on that. Alright guys, so notice any significant change? Nope, you probably don't. So that is a negative Benedict solution test. So what that means is there is no sugar present in this sample as we would expect, right? It's just tap water. There shouldn't be sugar in it. Okay, so I'm going to do exactly the same setup for solution or simulated blood B, and then we're going to let these guys sit overnight, and you're going to get a chance to see what we see tomorrow in about 24 hours. Okay? wrap on that one. So just remember, this is simulated blood B. Nothing is really different up until this point. So your Benedict's, that's another negative Benedict solution. So again, no glucose, which stands to reason, because once again, we're just using tap water. Now, like I said, we're gonna let these guys sit overnight, and tomorrow we're gonna come back and we're gonna take a look at what happened to our solution. Remember, these guys are simulating our nephron and what happens in the nephron. And if you guys remember, blood filters through the kidneys and produces urine. You're probably already starting to see some telltale signs of urine forming. All right, so that's a wrap for today, guys. I'll catch you tomorrow.
Bye.
Bye. All right, guys, we're back on day 2. Our simulated lab has sat, I guess it's been about 18 to 20 hours since I set this guy up. And so let's take a look at what we have now. Okay, so we have our 2 simulated urines. Notice the difference, guys. Remember yesterday we put this in just simple tap water. We had our simulated blood in this dialysis tubing. Remember, I told you this guy was semi-permeable, so you'll notice something pretty significant here. We have color change. This was simulated blood A, and this is simulated blood B. So go ahead and take note. Now, what does this water actually represent, guys? If you think about it, what do your kidneys actually do when they filter the blood? Yes, they pull off excess salt, excess water, and they send it off through the ureters to be stored in the bladder, where it can then be excreted as urine. Okay, so remember yesterday we did a few tests to kind of check this guy out. So in your lab table, you're going to want to note the color and clarity of your 2 samples here. Again, this is sample A and this is sample B. Okay, so now let's go ahead and get started. We'll run our biochemical tests. Remember, we did pH, we did salt, and we did a check for glucose. And those are all 3 items that you want to include in your data table as we go through this. Okay, so, all right, so first let's take a look at the pH. So grab some pH paper here. All right, guys, so there's our pH of our urine. It's still fairly yellow, guys. You know, we do expect our urine to be somewhat neutral in its pH, but I would say it's not quite as yellow as yesterday. I might call this urine more, maybe we can't really distinguish it specifically on these strips, but maybe a 6.5. Or 7 is okay as well. And again, we really do want our urine to be in a neutral pH. Okay? All right. So we're done with that guy. Let's grab a fresh paper towel. And now let's take a look at our sodium concentration. So put our urines back up here so you guys can see. And I'll write on the paper towel again. Okay, so let's take a look at this guy. So we'll hold in there for 2 seconds, and then we'll put it here, and then hold in there for 2 seconds, and we'll put it here, and then we gotta wait for 20 seconds. if you guys are able to tell as well in the camera, you can see, so there is a marked change from yesterday. And just the simple, just the basic tap water. Remember yesterday we had this 1500 parts per million. Essentially the strip didn't change. So it looks to me like strip A is probably closer to 2500 parts per million, and strip B here is about 2000 parts per million. So I don't know, I'll try to zoom in a little to see if you can see that in the camera. Okay, so hopefully you're able to get a glimpse of that. So again, in your table, you're going to want to note that sample A for salt is about 2500 parts per million. Sample B, we're looking more about 2000. Okay, all right. Back to our 2 urine samples. Remember, we have one more biochemical test that we're going to take a look at. We're going to take a look at sodium. Sorry, not sodium, glucose. And we're going to use this Benedict solution again. So remember, we need 5 mLs of Benedict solution. I better label my tubes, right? So I'm going to label one tube because I'm going to put them in this water bath for 5 minutes. So I need to know which one is which when they come out. So I've labeled my tubes, A and B. Okay, and remember from yesterday, we are going to take 8 drops of each sample and place it in the test tube with the Benedict solution. Okay, so sample A. To our hot water bath and put these guys in 4 minutes. All right, guys, that's it for our 4 minutes. I'm gonna go ahead and turn off our hot plate. I'm gonna carefully remove this and get it back to our workstation. All right, so one more time, there's our simulated urines. They're gonna come out here in just a sec. Here is a negative Benedict solution. So you can just remember that it's just this simple blue color. Okay, and let's go ahead and take a look at our 2 results. And remember, these are both gonna need to be noted in your lab. All right, so let me put on my glove here because this is probably a little warm. All right, so at first glance of tube A, you can see there's very, very little change, but if you look very, very closely, there is just a simple trace of yellow in this tube if you compare it to this tube. Okay, so there is a very, very slight change of yellow towards the top, and as you watched it boil, you probably saw that happening. So this guy has just a trace of of glucose in it, okay? Which we kind of sometimes expect in our diet. You know, our body has ways of compensating if we're consuming a lot of sugar. Now, if we start to see a lot of sugar, a significant amount of sugar dumped into the urine, then we might be dealing with something more like diabetes. So just kind of keep that in mind. Now this guy, on the other hand, here is a really strong positive result. You can see that brown literally sitting on top of the solution. So that is an indicator of positive glucose. So whereas the other guy said, the other tube A, we said that had a trace amount of glucose, we would say that this tube B has a moderate amount of glucose as resulted by this Benedict's test. Okay? All right, guys, so in a nutshell, in my face, in a nutshell, that is our lab. I hope you guys enjoyed watching. I know you would have enjoyed doing this lab. So hopefully we'll get back together and you'll get to do another lab before the end of the school year. But if not, know that I still miss you guys. I wish you were here. Our classroom is empty and sad. Rexy misses you all, of course. And I hope everybody is doing well, staying safe. I am going to post some discussion questions that you guys will need to answer to successfully complete this lab. Okay, thanks guys. Have a good one.